Now this is the Acer which had the PCH gone, i7 9th generation. I received the PCH. I received it a little while ago, but I was not prepared to install it or do anything with it. I don't know if this chip works either. We don't know anything. It has come pre-bold, and just in case I screw it up, I've also got stencil if we need to re-bold it. Hopefully we don't need to. And at the time of giving the quotation yes to a client, giving quotation and they're going ahead with it, I was not prepared at all. I'll rotate the camera. HDMI switch. Yeah, all the white hair, it's okay. Okay. It's it's the right, it's the other way around, okay. I've got here a WDS-720 and I received it for free. Free in a way that I'll do some jobs, for occasional jobs for the person donating the equipment. And I've been practicing with the equipment, and I have to tell you it's not easy, but once you get hold of it, it's okay. So I haven't figured out how to place the chip and weld the chip yet, but I practiced removing a chip at the same time popcorning the chips that I removed. Super IOs are easy. PCH are okay, they're the ones I popped. And these are some of the chips I've been working on. So shit, it's all flux, I'll show you. Okay, I'll have to change the glove. So PCH or Intel GPU, I don't know. These are all the motherboards. Another one. Another one. Lots of RAM memory modules. Super IO. It's possible. More RAMs. I've set up profile to remove these. They work fine. These I can do manually, the Super IO. And this PCH I also do manually. Sometimes I can get the machine to pick it up, sometimes I can't. It's a hit and miss. So these are all unfortunately popcorned during removal, which is fine, but also means that other components around that can move if I shake the motherboard, or components on the bottom side of the motherboard actually fall off if there's too much heat. So if you can see reflection, the popcorn effect, let me see, there we go. See those little bumps? I think more accurate will be here. So if you look at the edge there, let me see how I can do it. See those bumps? They're popcorn. See on those two there? Like that chip is gone. This one came out okay. This one have a lot of popcorn. This is I think the last one. Popcorn to death. But it came out perfect. All the pads are there and no pads removed off the motherboard. So the machine behind me, current value, about shipping alone is plus the tax. So GST will be about $800 Australian dollars, and then the customs fee maybe about 20%, so that's about 1,200, 1,300, and then plus the unit itself about 7,000. So it's quite an expensive machine. I've ordered bigger size nozzles, so the nozzles that I've got in there are just enough for the PCH, and they're smaller, nothing bigger. I've made orders from China, and they're still coming in. So until then, I mean, in the future, hopefully I can do GPUs or bigger PCH CPU packages. And business-wise, it's not really worth doing it in Australia because of labor cost. time consuming, etc. And not only that, the parts are expensive. So why would you get a PCH chip for with the CPU package for, you know, maybe 250 to 350 when you can buy the whole motherboard for $100 more on top or similar price? There's no point. And it varies by the generation, the CPU, etc., age of the laptop, etc. So it's hit and miss. It's not economical to invest in such a machine in Australia unless you have a batch of jobs you want to do that requires the machine, then yeah. But for laptop repairs, no. But if you do a lot of laptop repairs, you're in the business of it, then maybe it will be worth it in the future. So that's my PCH. Before I do anything, one thing I did want to check a while ago, I saw a video of a guy before he changed the PCH. He checked some of the capacitors on the chip itself, which made sense to me. Why not? If there's a short, you should be able to detect it on the capacitors. So that's the idea I'm going with. No, originally there's a video of this, you can see the PCH shorted, but I don't know whether the same testing will apply to this or not. So let's do that, let's do a test. So I'm very anxious and nervous about this job, because if I rip the pads off the board, see you later board, never done it before, so I have no idea what we're going to expect, but let's see. Okay, is that clear for you? Okay, that is clear. Let's bring the multimeter. Okay, we're in diode mode. We don't need power supply. Yep, okay. You can hear me? Okay, good. We don't need the schematics for another laptop. Alright. Okay, so let's see. Yeah, look at that. How easy is that to check for a short? 0, 0 to... Okay. And check in resistance mode. 2 ohm. That's my cable resistance. If I do ground to ground on the motherboard, I get 2 ohms. So okay. So we have a dead short, 100%. The PCH have to go 100%. Now the reason why the PCH has failed, most likely because of this. I don't know why the protections did not kick in from the USB port, the data lines, the resistors, to the PCH. I don't know. That's my assumption. That's why it may have died. I could be wrong. So the owner of the laptop took the challenge of giving this a go. He wanted to see how it will come out. I want to see how this will come out too. Okay, challenge accepted. Long time ago. Let's eat our challenge. Purposely rejected a couple of jobs so I can focus on this. I could be working with a lost cause. We don't know. Was that the 3-volt rail? Just out of curiosity. Spot on. Okay. So if we remove the PCH, that short should go away unless some of the other pins of the PCH is shorted to something else. Then, you know, we're in a bit of a shitty situation. So we will not turn on this board until we're 100% sure there is no more short anywhere on the board. That is any of the coils. Okay, this guy have 2 SSDs. We'll mark them, in fact. We'll mark them. Okay. Sharpie has a unique smell. In terms of recording the BGA rework station, I'll be using a mobile phone, so I'll be cutting OBS, we'll be switching over to the camera, I'll be doing video editing later, just joining videos, no trickery, no cutting scenes, everything raw, so these videos can be long. I can do Wi-Fi streaming, but when the machine is on, there's some interference and the Wi-Fi drops and frame rate drops. So I want to try and record at full 30 frames per second, full HD. Keep it as clear as possible. The zooming is not the best. We'll be using a Galaxy S7. I've got a Nikon, use it for family, and I don't want to get it messy with flux and rubbish on it. So okay, we'll keep those. We don't need to touch any of those. Okay. In the manual for the WDS-720 shit, you know, documentation of these machines are not always the best. You need someone physically to come and teach you and train you, and I don't have the luxury, unfortunately. I think for that machine you can go to China at their factory, they'll give you training. Even one of their videos was so shit, they just put a plastic dummy and pretend that it was heating it up and lifting up the component. So bullshit. Okay. Now, enough talking. Let's get down to business. So we need to prepare this board. So imagine high temperatures focusing here. We need to protect some components. We need to take some clear photos because components can get moved and then you'll need to figure out what happened, which part got lost. So I'll try and take some clear photos. Hopefully I don't get a phone call or something. Okay, that's that side. Let's remove this guy, because these ribbon cables are going to be exposed to high temperatures. Yeah, we've got some kind of disease that's lurking around. Okay. Sorry. Far out. We're a fucking dying breed, okay. This is what a newbie does when he doesn't know what he's doing. That will be me. Okay. One of the problem I have with the rework station I've got is it's not big enough. So here is a see that, you see that here? I actually cut a motherboard so I can have access to its PCH in a much easier fashion, so I can practice removing a BGA, a PCH chip. Use these are dead components. Nobody wants these. This is a socket probably from HP or something. Use a Dremel tool to cut it. Okay. So we can't really help it, liquid will seep in. So importantly, first thing first, I have to remove the plastic protection they put around the board, around the chip. So let's go ahead and try and remove them without damaging the board. So I practiced 2 times on other motherboards. So ideally use a plastic tool like this to pry it. Come in with a heat, probably about 150. You can do more. Just like that. If you're watching this to learn how to do it, like I'm not the guy for it, I am learning myself. So there we go. See how he just removed himself, apply a bit of pressure. It's really cool. There we go. SR40B, that's what I've got. In fact, I ordered 2 of them, but only one came through. The other one got cancelled. I have no idea why. Okay. Yeah, only 150 degrees. You can do more, but that's fine. See you later. So one thing to note is the direction. So we got dots on every side, but we have a triangle which will match with this triangle. This is the orientation, and we can see the line. Okay. Are you ready, motherboard? Oh, okay, I'm so nervous. Okay. Alright, we got a customer. Be right back. Okay, just some packages. Okay. So now, this is the flux I've been given with, can't remember with what. It wasn't this, it was something else, can't remember. And also, if anybody wants to comment, do comment positive, constructive things. If you have an argument or point to make, describe it. I would like to learn. I'm here for learning. So be constructive. Don't be a critic. Okay. Alright, I'm thinking, what else is there? What else I need to do on this? Should I remove anything here? We should be fine. Now it's just a matter of getting this chip to be in a position that my system will recognize it. So what I'm gonna do now, yep, okay. What I'll do, I'll let this recording run and I'll join this video later on. So have that open. We're gonna use a beautiful Galaxy S7 that was fantastic in its time. No more, his days are gone. Okay. Alright, so let's see. In fact, I'll rotate the camera around. Transform 180, that's better. What do you see? Let me see. That's fine, okay. Okay, let's try it out. Hello. Thank you. You too, mate. Problem is this board is too long. Okay, we've got a problem. It is not good. Yeah, I think this way it may work. Let me see. Oh, my back is gone. Okay. Still, if I can have it a little bit more this way. Can I? Oh yeah, okay, I've got it. Okay. So just to show on this camera, you can see the laser which is pointing from let me show you the laser. That's it. That's the laser point, which is pointing at the dot, and I've got to get that in the center. Okay. The board must be secure. We're going to put pressure later to remove the chip. Okay. Cool. All right. English. Curve select. 8888. Now that's the parameters I'm going to use to remove. Somewhere around here it's going to popcorn. Unfortunately, that's okay. We're going to have a 10-second alarm to get ready. Check if the chip is moving. If it is, we're going to let the suction do the job and lift it up. Okay. So we're going to say download the curve, meaning it's ready to be used. Semi-auto. So we do that. Should now go to a certain position, but not much. Okay, we'll bring more light. Okay. Alright, now we need coolant. Coolant is important. We don't want to kill ourselves. Okay, this is not affecting the light. It's going to be noisy. Maximum. Now there is a bottom adjustment. It must be close enough. There we go. Done. Now we need to do some manual adjustment. That's sufficient. And that is in the center. All right. Let me just think through what else am I missing. So we'll use this guy to check if it's in position. Okay. Just thinking. Semi-auto. Let me check the curve again. Yeah, 240 degrees for infrared. Okay. 220 may work, but this one we should have 100%. Here we go. Do your magic. No turning back. Yeah, okay, go for it. Run. And I'll have some coffee. And have a biscuit. Some packages came in. Okay, some Lego. Oh yeah, a HP purchase. This should be a keyboard. Chulara. So it's gonna come from China. Maybe it's something else. How's the curve going? First, second. Okay, we got some more. Alright, great. HP keyboard have arrived. Alright, now I'll pay attention to the chip. There we go. Okay. First, second, third. Third profile finished. Fourth profile starting. We're gonna go and grab the chip. No, let's see. Oh man, I'm so nervous. Okay. Just check. What is moving? I can't see. Shit, the pressure. Okay, if the chip is moving, I'm going to remove it. Bring it down. Suction, stop. There we go. Took it out. Okay, let the whole thing cool off. Hopefully none of the pads have come off of the chip and the motherboard. Chip is fine, but the motherboard, it's not good news. This one, the chip moves much earlier than expected comparison to the other chips I was practicing on. Could be the age, the solder they've used, maybe have a lower melting temperature. That's the problem with this kind of work. Every motherboard or age or thickness of the motherboard, so many factors, even the temperature in this garage makes a difference to the profile you use. Okay, so now we're going to remove the chip and I'll show you how we're going to remove it. Okay, chip is not important to us, but we'll have a look how we remove it. So here we go, this is how I remove my chip. Just like that. Delicious, yummy, chips who's hungry. Curious to see if I popped it. Let's have a look on the microscope. Now it's best if we wait for the BGA rework machine to cool down, so let it do its cooling. Okay, let's write our name here. Okay, sure can do. No bubble, maybe no. Good, that was a very clean rip-off. Pray no pads are here. Wow, I can't believe it. Fantastic. So where did it explode? Why did this chip die? Is there any marks? We don't know, but this is what it looks like. So pretty. And what's that one there? Okay. That's why I love these chips. Like I like collecting these kind of chips. They're very beautiful design, in fact. Like I really like it. Like someone spent time and detail into designing this. That's amazing. Okay, so now let's go ahead and remove our motherboard. So it's still cooling off. Let's have a look at here. As you can see, we were not that bad off in terms of centering it, but because there's a height difference, it will be a little bit off. So that's good. So now let's remove this guy. It's cooling off. Okay. Hold. There we go. Laser off, light off. Off. And we'll let it stay so it can cool itself. Alright, I'm gonna stop the recording here. Done. Okay, you may go to sleep. So now, let's have a look at here. Flip. Switch. Okay. Now let's see what mistakes we've done, if any components missing, etc, etc. Okay, that's a good focus. More light. Okay, here we go. I cannot believe it. Wow. Such a wonderful, wonderful job. I'm surprised myself. I am actually really totally surprised. Now, of course, the challenge is cleaning this mess without doing any damage to the board. And I doubt any components disappeared on the other side, because this was a very nice and clean work. Let me see if something like that did fall off, because when I put the nozzle down, I can verify that using the photos I've taken. Let me see. Where am I looking at? Which section? Am I looking there? Yes, and yeah, that side is just like that. No problem. So no issues there. So if you have a look at the photo I had taken earlier, so I was referencing using that and going to this side, and the resistors there, that side is empty. There's two caps there. So all good. Okay. Now the hard part. So we'll make this part 1, right? Now part 2 is very tricky, which is cleaning those pads without damaging anything. We'll do part 2 now. Thanks for watching. See you in the next one.